We're on page 2 of our product and quotient rule lecture packet. In this example 3, it says that a store has determined that the number of Blu-ray movies that they sell is given by this exponential function. X is the average price of the movies in dollars per movie. So I see from this function, just to start us off, if X is 0, we have an output value of 8,600. That means if the movies were free, they actually would be able to give away 8,600 movies. It also has a decreasing function. And so as the price gets larger and larger, they sell fewer and fewer movies. Okay, so that makes sense. Part A says find a formula for revenue. So we know revenue is price per movie times number sold. And so we know in this case we have a function here for the number sold, and we know that X stands for the average price per movie. So our function for revenue would be X times N of X. And we can then actually write the formula of that function, R of X. R of X is X times 8,600 times 0.932 raised to the X. Now it is standard that we generally write numerical coefficients out front. So this 8,600 here, I'm just going to switch it with the X. Instead of writing X times 8,600, I'm going to write 8,600X. That's just a more standard way to write that. So this function is 8,600X times 0.932 raised to the X. There is a revenue function that we plug in X that represents the price per movie, and it outputs the revenue they'll earn when they charge that price for the movies. All right. B says find the revenue and find the derivative of revenue when X is 10. So clearly we're going to need a formula for R prime. Our function R is actually a product of two functions. The first function I see here is 8,600X. 8,600X. The next function is 0.932 raised to the X. Maybe I'll put that in blue. So we have this R of X function, which is one function times another function. So I have F of X in red and G of X in blue. We know if we have a function that's a product of two functions, we must use the product rule. Product rule says we're going to take F prime G plus F G prime. I'll just note that right here. F prime G plus F G prime. So the F is in red, the G is in blue. I'm going to set up my little template. F prime times G plus F times G prime. In the first goes F prime. So F prime would be 8,600. G would be 0.932 raised to the X. F, I copy F, 8,600X. G prime, the derivative of that function in blue. The derivative of it would be 0.932 raised to the X times ln of 0.932. All right, there it is. That is our derivative R prime. Again, it can be simplified, but for right now, we're going to go ahead and just leave it as it is. And it asks us to find the revenue and find the derivative of revenue when X equals 10. So we're going to find R of 10. So plugging 10 into the revenue function. We're also going to find R prime of 10, plugging 10 into the derivative function. Now to do this, you could use your calculator, but I'm going to go ahead and use Excel to help us with this evaluation. In Excel, in my first column, I have X, the average price of movies. It asks us to plug in 10. In column B, I've put the revenue, R of X, the revenue in dollars. Notice that this function gives a value of 42,526.30 when you plug in 10 to the revenue function. So $42,526.30. When they charge $10 per movie, they will earn a revenue of $42,526.30. We also need to evaluate our prime function at 10. So to do this, I can just plug R prime into Excel. I'm going to take that function that I've highlighted in yellow and put it in Excel. And every time we're referencing X, I'm going to reference cell A2. So equals 8,600 times 0.932 raised to the X plus 8,600 times X times 0.932 raised to the X times ln of 0.932. So I get 1,257.82 approximately. Now remember, this is actually a slope. It's a slope. It's this number over 1, where the numerator is the change in y and the denominator is the change in x. In this case, the numerator is change in revenue. The denominator is change in price of the movies. So it's saying at a price of $10 per movie, if they raise the price by $1, the revenue will increase $1,257.82. Again, at a price of $10 per movie, so right at that instant, at that price, if they raise the price of the movies by $1 per movie, then the revenue will increase a total of $1,257.82. Now it asks us basically to do the same thing, but at 25. So since I put it in Excel, all I need to do is add in an X value of 25 and drag my formulas down. And I see now R of 25 is $36,968.88. Our prime of 25 seems to be negative 1124.68. So this means at a price of $25 per movie, the revenue is $36,968.88. At that price of $25 a movie, if they were to increase the price of the movies by $1 per movie, then the revenue would decrease $1,124.68. In example 4, it says the number of private donations in thousands received by a non-government disaster relief organization during the Xth hour can be modeled by this function, where X is the number of hours since a major disaster has struck. It first asks us to find a formula for f prime of x. So please first notice again, f of x is a product. F of x is a product. So if we want to find f prime of x, we must use the product rule. F prime g plus fg prime. And in this case, red is our f and blue is our g. All right, so here is our derivative function. Again, it asks us to evaluate f and evaluate f prime. I'm going to go ahead and do that in Excel, and then we'll be able to interpret the meaning. In Excel, in column A, I have put X, which is the hours after the disaster. So this is X is 20. And in column B, I have input our f of x function that was given to us, 0.3x times 0.9704 raised to the x. And now in column C, I'm going to enter our f prime function. So it equals 0.3 times 0.9704 raised to the x plus 0.3 times x plus 0.9704 raised to the x times ln of 0.9704. All right, and I get 6.148 approximately. All right, when I round here, it says that the f of x is the number of donations in thousands. So I'm going to go ahead and round my output values here to 3 decimal places. So f of 20 is about 3.290, and f prime of 20 is about 6.148. All right, and we want to interpret the real-world meaning of these values. All right, so it means 20 hours after the disaster, the organization receives about 3,290 donations that hour. The derivative, f prime of 20 equals 6.148. Remember, that's a fraction. Change in y over change in x. 6.148 over 1. It's 6,148 donations per 1 hour. So 20 hours after the disaster, the donations are increasing at a rate of about 6,148 donations per hour. That's increasing because it's a positive derivative.